Now we want to simplify it. Here x cube minus 27. So if we simplify it, limit x tends to 3. Here x cube minus 27, so x minus 3, and cube simplification, that is here first term square, that is x square. Then next term, that is multiplication with first and second, minus becomes plus, that is 3x, and then last term square, that is 9. 3 square, that is 9. Multiply with this term as it is, that is under root of x square plus 7 plus 4. Now here under root of x square plus 7 minus 4, and here under root of x square plus 7 plus 4, that is nothing but a square minus b square term. So our simplification, that is under root of x square plus 7 a square. So a at present under root of a square plus 7, so a square minus b square, b that is nothing but 4, so 4 square, and we write here this is nothing but a minus b multiply with a plus b, and the result, that is a square minus b square. Now we require to more simplification of our this term. So here limit x tends to 3, this x minus 3, so here x minus 3, here x square plus 3x plus 9, so x square plus 3x plus 9. This term we write here as it is, that is under root of x square plus 7 plus 4, and we want to simplify this term. So here under root and square both are cancelled out, so remaining term, that is x square plus 7 and minus sign as it is, and 4 square, that is 16. So again we want to simplify our denominator term. So here limit x tends to 3, we write this term as it is, x minus 3 x square plus 3x plus 9 as it is, this term also as it is, x square plus 7 plus 4 divided by x square as it is, and this plus 7 minus 16, the result, that is 9, and minus 16, the result, that is minus 9. Now just look at here x square minus 9, we can take a part, that is x minus 3 and x plus 3. So if we take a part, then the result, that is limit x tends to 3, write this term numerator whole as it is, x minus 3, here x square plus 3x plus 9, here under root of x square plus 7 and plus 4 as it is. Now two part, that is x minus 3 and x plus 3. Now we can directly remove this x minus 3 term, because both are common in numerator and denominator. Now if we replace the limit, then check our denominator. So here 3 plus 3 no any value, that is 0, so we can now easily replace the limit for this sum. So if we replace the limit, then sign must be equal to, and we want to more simplify this term again, so that is equal to 3 square plus 3 x by replace with limit, that is 3 plus 9 as it is, here under root of this 3 replace with this x square, that is 9 plus 7 and plus 4 as it is, divide by this 3 replace with x, so 3 plus 3 Now again we want to simplify this term. 3 square 9 plus 3 into 3 also 9 plus 9 under root of 9 plus 7, that are result that is 16 plus 4 as it is, and 3 plus 3, that are 6. Now again simplify. 9 plus 9 plus 9 27 under root of 16, the result that is 4 plus 4 as it is, divide by 6. Now 27 divide by 6, so here 9 into 3 and here 3 into 2, so here 9 divide by 2, and 4 plus 4. Now again we want to simplify, that is 8 and divide by 2, so 8 divide by 2, so here 4, here 2, that is ignore, and final the result that is 36. So we write our answer here, the result that is 36. Now we move to our next question. Next question, that is limit x tends to 0 under root of x plus a minus under root of a divided by x under root of x plus a. So we write it first here, limit x tends to 0 under root of x plus a minus under root of a divided by x under root of x plus a. So again we check whether we can directly replace our limit to this sum or not, but here x and here 0, so 1 upon 0 term, so we can't replace the limit, so we require to simplify this term here under root. So first step, that is use a rationalization term. So here limit x tends to 0, take a rationalization of numerator term, that is under root of x plus a minus under root of a divided by x under root of x plus a. Now multiply with numerator rationalization term, that is under root of x plus a, this minus sign becomes plus, and this under root of a. Same way this term divide, so here under root of x plus a plus here under root of a. Now look at this figure, under root of x plus a minus under root of a, and here under root of x plus a plus under root of a. So this is look like a minus b again, and this is look like a plus b. So the result that is a square minus b square. So here limit x tends to 0, a square, that is under root of x plus a square, because here a, so a that is under root of x plus a minus b, that is under root of a, and b square, that is under root of a square, divided by here term as it is x under root of x plus a, multiply with this term, replace here as it is under root of x plus a plus under root of a. Now we simplify our numerator term, this under root and this square, so finally cancel out. So limit x tends to 0 here, here remaining term, that is only x plus a, this under root cancel out because of square, minus also this under root are cancel out because of square. In this term we replace here as it is x under root of x plus a, and this term that is under root of x plus a plus under root of a. Now again we simplify this term. So here plus a, here minus a, so we directly remove it. Here x, and here also multiplication with x, so we can directly remove. So first of all write down whatever result, that is limit x tends to 0, no any value, so write here 1 under root of x plus a remaining term, and multiply with under root of x plus a plus as it is and under root of a. Now we more simplify. Here limit x tends to 0, so first step, that is we replace the limit, and our limit that is 0, so under root of 0 plus a multiply with under root again 0 plus a, that is a, and under root of a as it is. So we can say our denominator does not equal to 0, so we can easily replace the limit here. So if you replace the limit, then here sign that is equal to here 1. If we replace the limit x by 0, then only remaining term that is a, and here under root of x plus a, that is only under root of a plus as it is, and here under root of a. Now we simplify it, that is 1 under root of a as it is, here under root of a plus under root of a, the result that is 2 under root of a. And if now again we more simplify it, then under root of a multiply with under root of a, then a into 2, so we can write it here 2a. So this is our final answer, and the result that is 1 upon 2a. We write it our answer 1 upon 2a. Now we move to next. Our next part of the limit solution, that is now limit that is goes to up to infinite side. So up to now we have already discussed the part that is tends to 0. So next theorem, that is limit n tends to infinite, we write it here limit n tends to infinite, then if 1 upon n that is coming on our sum, then our result equal to 0, and if limit n tends to infinite and 1 plus 1 upon n raised to n, then the result that is e. So using this two base equation we solve our next problem. So first of all our problem that is based on this equation, limit n tends to infinite 1 upon n, and then we put result that is 0. So we move to our next sum that is limit n tends to infinite. Now our limit that is goes to infinite side, sum that is x into x plus 1 divided by x square plus 5x plus 6. So we now write it first, limit n tends to infinite x into x plus 1 divided by x square plus 5x plus 6. Now our aim, whenever limit that is goes to infinite side, then our sum must be converted into 1 upon n form. So we can easily replace it by 0. So here we simplify our term. So first of all limit n tends to infinite, right here as it is, and if we simplify it, then x multiply with first term, so result that is x square, and this x multiply with this one, the result that is only x, divide by this term we write here as it is at present, so here x square plus 5x plus 6. Now we want to term that is 1 upon n term or 1 upon x term, then we can say that divide by x square both the side, that is numerator and denominator, so we can write here x square plus x divided by x square all divided by this term, that is x square plus 5x plus 6 divided by x square. So this x square goes to both the side, so x square upon x square plus x upon x square. So we write it first here, limit x tends to infinite, we write it first this x square divided by this x square, so result that is 1 plus this x divided by x square, so result that is 1 upon x all divided by this x square divided by this x square, so result that is again 1, and here result that is 5x by x square, so result that is 5 by x, and this x square also divided by with 6, so result that is 6 by x square. Now look at here, our sum that is converted into 1 upon form, 1 upon x form, and our x tends to infinite. So if we replace the limit, then we can directly put result that is 0. So we apply limit both the side, so here limit x tends to infinite, limit apply to 1, and then plus here limit x tends to infinite, here 1 upon x